my name is Jordan Hernandez, and today I'm going to be going over Demo 7 Part 2, the microprocessor with controls. So, learning targets of Demo 7 to think about, we got 11B, 11A, and 11B. And these are some of the things I explained back at Demo 7, so if you guys want to know what those are, I'll let you guys watch Part 1. But for our problem, so back from Part 1, we made the LAU, which was to help us out to add 8 more operations into our microprocessor. So now we're going to update our microprocessor to basically become a little bit more automatic with the D flip-flops. That's my D flip-flop. So things to add to the microprocessor, the LAU from part 1, next state logic, which is D flip-flops, control logic, which is read, write, demux, clear, rags, and accumulate, out, and address generators. So here is what my next state table is going to look like: the present state, the inputs, the next state, and then my outputs, which is read, write, demux, clear, rags, and accumulate, out, and address. Now then my inputs are going to be start. So here's what my K-maps and equations are going to be looking like. I'm going to have 9 K-maps total, with 3 of the addresses coming from our next state logic, which were kind of easier to kind of determine. Or actually, no, it's from my present state logic. I'm so sorry. But yeah, for my present state, I got the address, all 3 addresses equations. But the other ones, I had to do K-maps. So here's what a clearer version of those guys look like. Yep. So, and then here's what my whole control system's going to look like. So this is going to be running on the side while I basically enter in just my address, and then I'm going to click start and then clock, and then whatever I'm going to input for my RAMs. But these are to help me out to kind of do basically from B, A, and then whatever RAM's going to be. Old microprocessor, so this is what it looks like with all the inputs inside of it. So our new microprocessor is going to be our control with the microprocessor to make it a little bit more automatic. So now to get out of this, I'd like to explain a little bit of this guy right here. This is to kind of help out a little bit more. So whenever our input data is, which is our ROMs, it's going to go through the data path, which is our wires. Our control thing is just going to be this guy up top. Sorry, I lost the picture. So when we receive external signals, which are going to be my start and my clock, and then restart is going to be an external signal just to kind of restart the whole data. We have control signals are going to be sent into the data, which control our data path, but then our data path is going to send us data signals, which are going to be whatever inputs we get from our ROM. It's just going to be put into the controls like the registers and stuff. And our output data for now is going to be RAM. But RAM later on will also be our input data, as this is a full cycle. So now we got that out of the way. So here's what I'm going to have. So we're going to start with the operation of 8 plus 3, which is going to be equal to 11, but hexadecimal, it's going to be B. So we got state 1, we're going to have ROM 1. State 2 is going to be 0, and then state 3 is going to put out to RAM 7, which is going to be B. I know it shows 9 right now because I was running this a little earlier. So when we click the auto thing, it's going to output as B, which is we got right there. So that is our addition, and then we have select mode as 1. So then now I'm going to turn off the clock, and then now we're going to do B minus 2. So we're going to bring this all the way back to 0. And then now we're going to make mode. So state 2, or state 1 is going to be 2, and then state 2 is going to be 7, because we want it to be B minus 7. So it's going to be ROM 2, or RAM 7 minus ROM 2, which is going to be our 2 input. And then our state 3 is going to be 6, because that's where we want our new answer to output to. So when we now click through all of this should going to be output to 9. There we go. As we can see, it outputted to 9. So now we know that this is working. We can now go through our new operations, which is something from our professor. So our first thing is that we want to do 5 plus 4. So ROM's going to be 5, 4, 5. And then ROM 3 is going to be 4. 1, 2, 3, 4. And then another one is that ROM 1 is going to be 6. And this is for an later operation. So then now we're going to have state 0 be first, state 3, and then state 2 is going to be ROM 3, and then state 3 is going to be RAM 7. Because this is where we want it to be outputted. And since we want it to be addition, we're going to have it right there. So this hopefully should output as 9. So let me run that C. There we go. Now we have 9. I'm going to turn off the clock again. And then now we are going to do our multiplication. So this multiplication part, I'm going to have to explain. So LS4 is going to be our last four digits of 54s, which is going to be 0, 1, 1, 0. And then MS4 is going to be 0, 0, 1, 1, which is going to be 3. But however, it's going to represent our first 4 of 54. So in total, it's going to look like 0, 0, 1, 1, 0, 1, 1, 0, which is going to be 54. But I'm going to have these guys to kind of know that if it's LS4 and it's 6, we're good. And if it's MS4 and it's 3, then we're good. All right. So now we are going to operate that. So we're going to start from RAM 7. And then we're going to have it in state 2 being 1. And then we're going to have that all put into state 5, which is or state 3 is going to be state 5, or going to be 5. But you get it. All right. And then we're going to have it where it's 2. So then turn that on. Now this should output as 6. There we go. So now we know that LS4 is working. We can now move on to 3, which should be 3. There we go. All right. But yeah, just a little reminder that even though it's like 6 and then 3, it's just going to output as 54. It's just a little bit complicated because we're doing 4 bits of binary. If it were to be 6, then it would be a little bit more easier to see 54. But since it's hexadecimal, it's probably going to output as a letter. But other than that, I think that's about it. I hope you guys enjoy, and I'll see you all next time. Bye.